On July 1st, the Atlas system in Rio Hurtado Observatory in Chile detected something unusual. Actually, let me be more specific: the strangest object we've ever seen. Unlike other objects, its trajectory cuts right through the inner solar system, passing close to planets like Jupiter, Mars, and Earth. This tells us two mind-blowing things. First, the object trajectory screams interstellar origin. Second, the trajectory itself is incredibly unique. We're talking 1 in 10 million odds, which leave us wondering, maybe this isn't a coincidence. 3I Atlas is the newest of three known objects representing a unique class of celestial bodies. You probably remember the scientific buzz 8 years ago around the mysterious object Oumuamua, that massive cigar-shaped rock that was initially mistaken for a comet but turned out to be nothing like one. It had no visible tail of evaporating ice and was hauling ass at 26 km per second. Within the first few days of discovery, the internet exploded with headlines. And for good reason. Oumuamua was the first object we'd ever seen visiting us from another star system. Its shape and behavior made scientists question whether it was natural at all, leading to speculation that Oumuamua might be alien-made. History is repeating itself with 3I Atlas, but on a completely different scale. And it's not just because the internet loves clickbait. These newly discovered objects stand out from its predecessors. It's dozens or even hundreds of times larger than Oumuamua, and its orbit cuts directly through the inner solar system like a bullet, flying at an unimaginable speed of 61 km per second. But here's what really blew scientists' minds. Atlas comes from a star that no longer exists. That's how leading interstellar object expert Michel Bannister characterized 3I Atlas. This is the oldest comet we've ever observed. It's between 7 and 11 billion years old, older than our solar system and potentially older than the Milky Way itself. Scientists are looking at a magnificent opportunity to study one of the most ancient objects in space, containing water and organic compounds from the era when the very first star systems in our galaxy were forming. But this event remains so strange, so defiant of logic, that some scientists seriously believe 3I Atlas is an object of alien origin. It's estimated that up to 10,000 extrasolar bodies pass within Neptune orbit every day. But these three discovered objects are different. They don't just peek into our system, they visit its most important part, passing within a few 100 million kilometers of the Sun. By cosmic standards, that's incredibly close. It's like spotting a single person if Earth's population dropped by 1,000,000 times. 3I Atlas is an incredibly rare event, not just by the standards of our history, but by the standards of the entire universe. Despite being brand new, it's making the brightest minds of humanity both wonder and worry. To unveil the mystery of 3I Atlas, we need to dive into the history of studying extraterrestrial objects, these cosmic wanderers, understand their origins, and reconsider our ideas about our home solar system, life, and even ourselves. How would you react to seeing a comet in the sky if you had no idea what is this? I'm sure some of my viewers might have experienced something like this in early childhood, when everything seems strange, amazing, and mesmerizing. Comets made similar impressions of people throughout history. Humanity has always regarded them with mystical awe. In ancient Greece, comets were depicted as severed heads with flowing hair. The word comet literally translates from Greek as hairy. People were wary of comets back then because, according to ancient beliefs, women could only wear their hair loose during mourning, so the appearing of a comet or hairy star inevitably foretold sorrow. The first documented comet observation dates back to 2296 before Christ, when Chinese astronomers tracked its movement through the constellations. In their worldview, the sky was a vast empire ruled by the sun and consisting of numerous regions and provinces, with planets serving as local rulers. In this celestial political system, comets represented couriers delivering imperial decrees. Only China developed a positive view of comets. As I mentioned, the Western world saw them as symbols of impending disaster. The ancient Babylonians left poetic but ominous descriptions. Each shone with a daylight and dragged behind it a tail like a scorpion's sting. This comet description dates to 1140 before Christ. These disruptors of the eternal and unchanging cosmic order struck fear into the hearts of even great thinkers and philosophers. A Roman naturalist Pliny the Elder compiled a detailed classification in the 1st century, distinguishing at least 11 types of comets. There were lamp comets that illuminated the sky with bright light, goat comets with forked tails, spear comets threateningly aimed at Earth, dagger comets with sharp rays, comets with silver tails, and even barrel-shaped comets. Each type foretold its own troubles, wars, epidemics, the deaths of rulers, or natural disasters. Roman augurs interpreted comets' shape, color, and direction differently, affecting the final prediction each comet carried. But regardless of characteristics, nothing good was expected from comets. History preserves many dramatic coincidences. In 44 before Christ, a bright comet's appearance coincided with Julius Caesar's death. Medieval chronicles overflow with descriptions of terrible comets. French physician and alchemist Ambroise Paré described them in the 16th century. On both sides of the race emerging from the comet's tail, one could see many axes, knives, and blood-stained swords, and among them terrible human faces with D-shaped birds and hair standing on end. Gradually, the attitude toward comets as bad omens began to fade. The Roman philosopher Seneca came closest to comets through nature in the 1st century. Arguing with Aristotle, who considered comets atmospheric phenomena, he wrote prophetic words. I cannot agree that a comet is merely kindled fire. It is rather one of the nature's eternal creations. A comet has its own place among celestial bodies. It describes its pain and does not fade, but only moves away. The time will come when persistent work will reveal the truth now hidden from us. That time would come only 15 centuries later. Paradoxically, one of the history's most feared comets became the key to understanding their true nature. Of all 400 comets known before the telescope's invention, one was Specialized comet that regularly visited our planet like a clockwork every 75 years for millennia. The celestial wanderer appeared in documented human chronicles at least 30 times. It witnessed the fall of the great empires and the birth of new civilizations. Chinese historian Sima Chan first accurately described it in 240 before Christ. First it appeared in the east, then it was seen in the north, and finally showed up in the west. No one yet understood this was the same celestial guest returning to us again and again. This comet, the only short-period comet easily visible to the naked eye, launched our study of these celestial bodies. With each visit, it transformed from a terrifying omen into a triumph of human reason. The comet got its name from English astronomer Edmund Halley, who, studying historical records of bright comets in 1531, 1607, and 1682, noticed striking similarities in their orbits. After calculations, he made a bold assumption. This was the same comet regularly returning to us from the depths of space. Halley predicted the comet's next appearance in 1758. He died 16 years before he could verify his prediction. It lit up the sky on March 13, 1759, becoming a true triumph of Newtonian mechanics and the first successful astronomical prediction in history. Halley's comet holds a special place in human history. It's the only comet you can see twice in a lifetime. Each appearance left its mark in world chronicles. Its appearance in 44th before Christ coincided with the great Roman emperor's death. In 1066, it appeared before the Battle of Hastings between Normandy and England. The Anglo-Saxons perceived the celestial phenomenon as a bad omen foretelling defeat by the Normans. The comet also appears on the famous Bayeux tapestry, becoming perhaps the first authentic comet depiction in history. Interestingly, scientists chose symbolic dates for major comet missions. The European probe Giotto wasn't named after some astronomer as usual, but after artist Giotto di Bandone, who depicted Halley's comet in his fresco Adoration of the Magi in 1305. The Americans specifically planned their visit to Halley's comet for Independence Day and Valentine's Day. The comet last visited our planet in 1986. Right at the end of the space age, when humanity was more ready to meet it than even before. A real space fleet was sent to the comet, the so-called Halley Armada. This was the first international space operation to study a comet coordinated by an informal group of space agencies. Creating the Armada was so important milestone in the international cooperation during the Cold War. The fleet included Soviet craft Vega 1 and Vega 2, which first studied Venus, then headed to the comet, ESA's Giotto probe, and Japanese interplanetary craft Suisei and Sakigake. Mission preparation involved enormous technical challenges. Landing on a planet's surface, a huge object compared to a comet that's relatively easy to catch and land on, is one thing. But fishing on a tiny fragment moving at 70 kilometers per second relative to the spacecraft from infinite cosmic space is quite another. This incredibly complex space mission started on December 15, 1984, before Vega 1's launch. The spacecraft were to meet the comet in March 1986, at about 150 million kilometers from Earth. Fantastic precision was required. All maneuvers had to be calculated a full year and a half before the actual flight to the comet. On March 4th, Vega 1 began transmitting the first comet images from 40 million kilometers away. For the very first time in history, humanity saw a comet's nucleus with its own eyes. But what scientists discovered overturned all ideas about comet's nature. First, the comet's color was shocking. Instead of an expected brilliant bright snowball, scientists saw a coal black object with an albedo of just 2%, darker than asphalt. The comet reflects less light than coal. Halley's comet turned out to be the darkest object in the solar system. On the March 6, Vega passed at a record distance of 8,000 kilometers from the comet's nucleus, and 3 days later, Vega got even closer. Flight speed reached an incredible 78 kilometers per second. During this rendezvous, the spacecraft were bombarded by cometary particles, damaging Vega 1's batteries, but both probes heroically withstood the attack and continued transmitting precious data to Earth. European Giotto risked getting even closer, just 596 kilometers from the nucleus. Thanks to Soviet craft data, which acted as scouts, Giotto was precisely aimed to the target. On March 13, the probe's color camera captured the comet's nucleus in incredible detail. It wasn't smooth and symmetrical, but had an irregular shape, roughly 15 by 8 by 8 kilometers, like a giant potato covering in dark crust. Temperature measurements were even more surprising. The comet's surface was heated to 30 to 130 degrees Celsius, though it was expected to barely reach minus 100 degrees. The explanation for such high temperature was incredible. Scientists discovered that only a tenth of the comet's surface was active, with most covered by a layer of dark dust consisting of carbon and organic compounds. This dust crust absorbed solar heat, creating powerful jets of evaporating gases from isolated areas, cosmic geysers, so to speak. The data completely changed our understanding of comet physics. The classic dirty snowball theory proposed by astronomer Fred Whipple proved inaccurate. It turned out to be the opposite. Comets are dirty clumps with eye inclusions. The comet's nucleus is not a single solid body, but a loose collection of weakly connected fragments, rocks, and grains with an average density 1.5 times less than water. Chemical analysis revealed amazing diversity of chemical compounds. Besides water ice, the comet contained carbon monoxide, methane, ammonia, iron, sodium, hydrocarbons, and hydrogen cyanide. Organic compounds were particularly intriguing, building blocks of life preserved since before the solar system formation 4.5 billion years ago. If all this isn't enough, here's the most interesting discovery scientists made. Analysis of the comet water composition was very strange. As we know, water contains some deuterium, a heavier hydrogen isotope. In Earth's ocean water, there's on average one deuterium atom in every 6,420 regular hydrogen atoms. In Halley's Comet and other Oort cloud comets, this ratio was twice as high. This challenged one of physics' most persistent hypotheses. Comets couldn't have been the source of Earth's oceans, as previously assumed. If comets didn't bring water to our planet, where did it come from? Maybe asteroids were the source? Or did water form in Earth's interior? What if there are another types of comets whose chemical composition better match Earth's? These questions became even more puzzling when astronomers discovered that some comets from the Kuiper belt have deuterium to hydrogen ratios practically identical to Earth. Comet Hartley 2, studied by Herschel Observatory, turned out to be the chemical twin. It turns out there are at least two types of comets in the solar system with different water isotopic compositions. Some from the distant Oort cloud were saturated with deuterium, others from the nearby Kuiper belt were relatively light and matched Earth's water composition. But the small family of light water comets wasn't enough to explain all 1.5 billion cubic kilometers of water in Earth's oceans. Thus, the Halley Armada not only revealed the secret of the most famous comets, but also raised new questions about life's origin on Earth. If comets didn't bring water to Earth, then what did? Where should we look for the real source of this amazing substance without which life and we ourselves wouldn't exist? The answer lies in the dramatic events of our planet's early history, when the solar system was an arena of cosmic catastrophes on an unprecedented scale. While scientists puzzled over the deuterium mystery, the solar system prepared to show us one of the most dangerous events in observational history. On March 21, 1993, Caroline and Eugene Shoemaker, together with David Levy at Palomar Observatory, discovered a strange object they dubbed a string of pearls. A comet turned into 21 fragments by Jupiter's tidal forces. Trajectory calculations show a green picture. The fragments of Comet Shoemaker-Levy 9 were flying straight towards the gas giant. Astronomers had an incredible opportunity to prepare in advance for the impending cosmic collision. The whole scientific community held its breath. We were becoming witnesses to a cosmic catastrophe in real time for the first time. On July 16, 1994, the first comet fragment crashed into Jupiter's atmosphere at 64 kilometers per second. The impact energy was 6 million megatons, 715 times more powerful than all existing nuclear bombs exploding together. The fireball, heated to 24,000 degrees, rose 3,000 kilometers above the planet's cloud deck. But the most important discovery awaited scientists in understanding what happened. The collision revealed Jupiter's no obvious role in the solar system cosmic shield. With its powerful gravitational field, the gas giant captures and absorbs dangerous comets and asteroids that could threaten inner planets, including Earth. Without Jupiter, our planet's history could have unfolded completely differently. Calculations show that the number of large collisions with Earth would be hundreds of times greater. Perhaps life on Earth could emerge and develop precisely thanks to our cosmic guardian angel. Thus, Comet Shoemaker-Levy 9, which could have wiped all life off Earth, simply became another victim of Jupiter. However, Jupiter's gravitational shield can also play a cruel trick. Sometimes the planet might not absorb but deflect objects, attracting and ejecting them into the solar system's inner part. Jupiter's dual nature, protector and troublemaker simultaneously, forces us to constantly monitor small body dynamics in the solar system. After the Halley Armada's triumph and Shoemaker-Levy 9's dramatic impact, scientists understood. To solve Comet's mystery and find the answer to Earth's water origin puzzle, bolder approaches to studying these small objects were needed. Just observing even at arm length no longer satisfied them. It was time to touch comets or even attack them. On February 7, 1999, NASA launched the Stardust probe, the first mission in history to deliver comet material to Earth. The goal was audacious: fly to Comet, pass through its coma at over 6 km per second, and collect comet dust samples in a special substance, aerogel. On January 2, 2004, Stardust approached the comet to 240 kilometers. Its surface was pitted with flat-bottomed craters with steep walls, created a landscape of ice and rock. Powerful gas jets erupted from these craters, resembling cosmic geysers. The treasure reached Earth on January 15, 2006, when the sample capsule fell into scientists' hands after traveling over 4.5 billion kilometers. Opening the capsule, specialists had the opportunity to examine real cosmic treasures, particles of ancient comet material untouched for the billions of years. Simple analysis led to sensational discoveries. They found olivine, a mineral that forms at temperatures around 1500 degrees Celsius, and osbornite, a substance that crystallizes at 1700 degrees Celsius. How did high-temperature materials get into an icy comet from the solar system's distant outskirts? Only one possibility. Once, at the dawn of the solar system, large-scale material mixing occurred, when material from hot inner regions was somehow transported to the cold periphery. However, all this, Stardust's incredibly complex mission and the revolutionary discoveries it brought, was just a warm-up before an even more ambitious mission. On January 12, 2005, NASA launched Deep Impact. Its task was truly wild: attack a comet by dropping a 370 kg copper projectile and observe the debris exposing the comet's nucleus. Deep Impact turned out literally patriotic. The probe dropped its projectile right on the Independence Day. The projectile's collision with Comet Tempel 1 occurred at 10 km per second. The explosion, equivalent 4.7 tons of TNT, ejected a fountain of material weight 10,000 tons from the comet. The comet's brightness instantly increased sixfold, a holiday firework visible even through the amateur telescopes. These unusual mission results were even more unexpected than Stardust's. The comet turned out to be 75% empty. At the same time, it contained high-temperature minerals, organic compounds, and huge amounts of carbon-containing substances. It turns out comets are time capsules storing both high-temperature materials from the early solar system inner regions and pristine ice from its distant outskirts. In 2011, the Stardust spacecraft photographed the crater left by the Deep Impact mission on Comet Tempel 1. Its size was much smaller than expected, only 150 meters in diameter and 30 meters deep. This confirmed the hypothesis that comets are incredibly fragile and porous. After decades of research, our understanding of comets has fundamentally changed. Today, we know they are not just dirty snowballs, but complex bodies formed the material from different eras and regions of the solar system. They also clarified the deuterium mystery. It's quite possible that Earth's water came from comets hanging around Jupiter. Amino acids protein building blocks, particularly glycine and complex organic molecules, were also found in comets. We can only guess how significant this contribution might be to the panspermia hypothesis, the possibility that comets could have brought not only water, but also life's primary components to Earth. The most surprising discovery of recent years has been dark comets, objects that look like asteroids but show non-gravitational acceleration characteristics of comets. These mysterious bodies might represent a completely new class of objects we haven't yet studied as roughly as physical theories require. But all this pales in comparison to what happened on October 19, 2017, when all our comet theories nearly crumbled. No one was prepared for this. On that day, forever etched in astronomy textbooks, the Pan-STARRS telescope in Hawaii detected an object unlike anything we'd ever seen. Frankly, unlike anything we'd ever expected to see. It moved so fast and along such a strange trajectory that it was passing right through the solar system's gravitational field, originating from a completely different star system. For the first time in observational history, humanity saw a visitor from another star up close. An object that stirred the scientific community and glued millions of people to tabloid headlines, screaming that we witnessed the first alien contact. October 19th, 2017 didn't promise anything new. Canadian astronomer Robert Wyrick was pulling his shift at the main computer of Hawaii's Haleakala Observatory atop Mauna Kea volcano. The magnificent sky in such places subconsciously instills a sense of peace and universal goodness in everyone who looks at it. It seemed like it had always been, it would always be this way, and nothing could disturb it. Suddenly, the peace was broken. A barely visible dot appeared in the sky, moving in a way that seemed very strange to Eric. In one moment, the astronomer was gripped by mixed feelings between childlike wonder and the worst nightmare imaginable. The object he discovered wasn't like anything we knew back then. This object's motion cannot be explained by any ordinary asteroid or comet orbit. This object came from the another star system. Thus began one of the most captivating and controversial chapters in modern astronomy. Over the past 8 years, humanity has encountered 3 interstellar travelers that forced scientists to reconsider our understanding of space and even speculate about encounters with alien civilizations. In 1973, Arthur Clarke penned one of science fiction's most significant works, Rendezvous with Rama. The novel takes place in 2131, when humanity has already colonized the solar system. Suddenly, Space Patrol discovers a massive cylindrical object tens of kilometers long, dubbed Rama. Initially mistaken for an asteroid, its trajectory, angle, and high relative speed indicated this object came from deep space. An investigation ship was sent to the asteroid, discovering that Rama wasn't an asteroid but a huge spacecraft with cities and artificial seas inside. The ship was inhabited by biots, biological robots flying toward the Large Magellanic Cloud. As I mentioned, the novel caused a sensation, so much so that scientists seriously dedicated to test Clarke's idea and consider whether Rama could exist in reality. 3 years after the book publication, a work titled The High Frontier: Human Colonies in Space appeared, where American physicist Gerard O'Neill presented a project for space exploration using huge cylindrical colonies. This book also resonated and confidently formed the stereotype that if alien civilization engage in cosmic expansion, they would do it with cylindrical ships like Rama. And so, 41 years later, we found such an object. The glowing dot, discovered by the Panoramic Survey Telescope and Rapid Response System, was moving toward Pegasus constellation at over 26 kilometers per second. It had already passed Earth 2 weeks earlier and was 32 million kilometers away. Action was needed immediately. Robert Wary contacted his colleague Karen Mitch from the Hawaii Institute of Astronomy. Her first thought was, did this really have to happen today? It was Sunday, and Mitch had just returned from the Another Planetary Science Conference that has taken up her weekend. But immediate action was required. Together, Warwick and Mitch frantically started sending applications to Reserve Telescope for more detailed observations. Within 24 hours, the world's largest telescopes were activated. The Very Large Telescope, Keck Observatory, and Hubble at Spitzer Space Telescopes. More detailed observations led to the following conclusion. Over 8 hours, the object's brightness changed about 10 times, indicated it had a highly elongated shape, like a cigar, a rotating cigar. The object width was about 100 meters, with length exceeding it roughly 10 times. Astronomers had never observed celestial bodies with such characteristics. Initially, the object was designed C2007U1, then reclassified as A2007U1, but the name Rama appeared much more frequently in mentions, implying the object's artificial nature. Studies of the object's spectrum and surface composition revealed another surprise. The object's non-gravitational acceleration was about 17 meters per second squared. Seemingly small in nature, but it needs explanation. Comet acceleration is a common phenomenon. Comet nuclei, consisting mainly of ice, begin to evaporate under solar heat when approaching the Sun, forming a huge tail called a coma, then contributes to the comet's reactive motion. The comet's speed increases through mass ejection. By measuring the deviation from calculated trajectory, the comet's acceleration, you can easily calculate what portion of the nucleus was evaporated to provide additional impulse. Spectral analysis showed that Rama should have lost about 10% of its mass, and if it were an ordinary comet with an icy nucleus, its tail would be visible even to the naked eye, but it wasn't visible even through the most powerful telescopes. Another oddity was that with such significant gas evaporation, Rama would start spinning faster and faster and fall apart. Therefore, something other than reactive motion was accelerating the object. Its movement simply defied physics law. Scientists couldn't explain the visitor's motion anomaly, and the alien spacecraft hypothesis became increasingly popular. Powerful ratio telescopes were deployed to listen for Rama's radio emissions, but no suspicious signals were detected. Professor Abraham Loeb of Harvard University tried to determine whether this was an ordinary rock or a stealth scout. He suggested that the extrasolar object's specific shape and acceleration could be explained if it represented a relatively small space probe with a solar sail. As Loeb himself said, he followed Sherlock Holmes' principle. When you have eliminated the possible, what remains, however improbable, must be the true. Four key arguments supported this assumption. First, the strange cigar-like shape possessed by no known asteroid. Second, high albedo, reflecting ability resembling polished metal. Third, anomalous no gravitational acceleration without mass loss. Fourth, an extremely strange flight trajectory. Clarke's reaction to such a statement was immediate. The hypothesis was deemed unscientific and even speculative, but by then it had already left a serious impression on public consciousness. By then, the visitor had received an official name. Many wanted to call it Rama, but the International Astronomical Union named this mysterious object after the region where it was discovered, Oumuamua, meaning first messenger in Hawaiian. In 2020, a more plausible hypothesis for Oumuamua's acceleration was proposed. Cornell University professor Daryl Seligman suggested the object was indeed experiencing reactive motion, but this motion was experienced not by icy evaporation, but by hydrogen gas release. Such gas is impossible to detect through telescope observations and could emerge from ice sublimation and structural rearrangement inside the object's nucleus. I constantly call Oumuamua an object because it can be called either an asteroid or a comet. It's a completely new class of cosmic bodies, a dark comet with an invisible but present coma. Scientists began wondering, are there other dark comets besides Oumuamua? Carefully studying solar system catalogs, 6 objects experiencing anomalous non-gravitational acceleration were found. These turned out to be small asteroids up to 3 meters in diameter orbiting Earth. Their acceleration was so small it seemed practically imperceptible, but their behavior resembled our visitors. The number of mysteries surrounding this anomalous object required searching for another Rama. The Oumuamua story allowed developing methods for detecting and studying similar objects, and less than 2 years later, a second visitor appeared in a telescope view. It was discovered by amateur astronomer Gennady Borisov from his observatory in Crimea. The object designed to I. Borisov turned out to be the first discovered interstellar comet. At discovery time in August 2019, it was about 500 million kilometers from the Sun. As with Oumuamua, professional observatories joined comet observations. Within a month, they determined it was moving on a hyperbolic trajectory, rounding the inner solar system at 32.2 km per second. faster than Oumuamua. In December 28 that year, Comet Borisov approached Earth at the maximum close distance of less than 2 astronomical units. During approach, astronomers conducted the most detailed object observations, revealing the interstellar wanderer's tail was 14 times larger than our planet and contained iron and magnesium particles, plus water and tholins, typical of solar system comets. Thus, we confirmed that comets in the different stellar worlds are almost identical to each other. Unlike mysterious Oumuamua, Comet Borisov behaved correctly. It had a pronounced comma explaining the object trajectory, but mysterious remained. For example, why Oumuamua and 2I Borisov differed. Moreover, Comet Borisov had carbon monoxide concentration several dozen times higher than ordinary comets. Simply put, this object consists mostly not of water ice but dry ice, which can only form at very low temperatures below -251 degrees Celsius. This indicates Comet Borisov could have formed by a completely different mechanism that the comets were used to. Based on observations of Oumuamua and 2I Borisov, astronomers concluded that at least one such object should visit the solar system monthly. Most are now part of our star system, slowed by the Sun and Jupiter's gravity. One such object was Comet Hyakutake, which passed Earth at a record close distance of 50 million kilometers in March 1996. Its extrasolar origin is indicated by its elongated elliptical orbit and very unusual composition. Incidentally, Comet Hyakutake was so bright it temporarily outshone the famous comet Hale-Bopp. Speaking of which, this comet also generated many rumors and assumptions. It all started with a photo where the comet resembled a UFO. Ufologists worldwide agreed that an alien spacecraft was following Comet Hale-Bopp. This all led to the tragic Heaven's Gate story. I mentioned this as another reminder that Oumuamua isn't the first victim of ufologist attacks. By the way, if any of you managed to observe Comet Hale-Bopp live, please share in the comments what it was like. I and other viewers would be very interested to know. Besides comets and asteroids, there are meteorites of extrasolar origin. The previously mentioned Abraham Loeb analyzed existing cosmic bolide catalogs and noticed a body that exploded in Earth's atmosphere on January 8, 2014, over the Pacific Ocean. It was moving at over 42 kilometers per second and later received designation IM-1. Subsequently, space monitoring systems confirmed this body came from beyond the solar system. Another similar object entered the Earth's atmosphere over the Atlantic Ocean. According to the most likely hypothesis, these objects are bullet-shaped fragments ejected by supernova. All these objects, large and small, are important for modern science. While Comet Borisov, roughly speaking, doesn't represent such interest for us, Oumuamua attracted scientists' attention worldwide. A huge shortcoming was that it was discovered only 40 days after passing near the Sun. By discovery time, Oumuamua was already 33 million kilometers from Earth. Perhaps we could have solved this object's mystery if it had been closer. With limited data and unresolved questions, the scientific community agreed that the only way to learn more about Oumuamua was to send a mission after it. Catching up to an interstellar object is a serious challenge for several reasons. First, Oumuamua is now over 6 billion kilometers away, roughly the same distance as Voyager 1 when it took the famous pale blue dot image. It's moving away from Earth at over 26 kilometers per second. No existing chemical rocket can reach such speeds. Even assuming we could accelerate a probe to the necessary speed, The problem of slowing it down remains because otherwise it would simply fly by without providing any information. Third, Oumuamua is an incredibly small object. It's not a needle in a haystack. It's a pea in a huge field the size of Earth. Despite calculations and navigation, determining its exact location is incredibly difficult. Given signals, delays of several days, shooting at the target would have to be done right from the solar orbit, making this task practically impossible today. The most realistic possibility for sending a mission to Oumuamua is the Lyra project, according to which a probe could leave the solar system at over 70 kilometers per second thanks to series of gravitational maneuvers around the Sun and gas giants. If we agree that the mission launch would occur between 2030 and 2032, arrival at Oumuamua could happen in 2048. However, several previously mentioned conditions continue to keep this idea's assessment at a skeptical level. According to calculations, if Oumuamua had been discovered even a year earlier, we could have organized a mission to it around its Earth flyby. Given this fact, the current trend in searching for and studying extrasolar objects is developing as follows. As I mentioned, according to calculation, an interstellar object like Oumuamua passing through the inner solar system at least once a year. Using powerful telescopes like the Vera Rubin Observatory, astronomers will be able to detect such objects 3 months earlier than currently possible. Along with this, the European Space Agency is actively considering launching the special Comet Interceptor mission, which will launch a probe in 2029 to patrol space for interstellar objects for 3 years. When observatories detect such an object, the probe will maneuver and intercept it. Comet Interceptor will be the first mission in history with an unknown target. Despite today's apparent seriousness, all the events I've described seem like mere coincidence, chance, even luck that wasn't destined to happen again. People struggle to fully grasp the universe scale. We feel comfortable in our small cosmic cradle, but there, beyond the heliopause, lies the cold oblivion of interstellar space. Until now, we only knew of 2 objects that crossed the solar system's boundary. 2 Voyager probes sent into cosmic void decades ago at over 15 kilometers per second. Then we met bodies that made the reverse journey from the space into the solar system, Oumuamua in 2017 and Comet Borisov in 2019, which brought excitement and even something akin to fear of cosmic death. When Comet Borisov disintegrated into fragments, leaving only a cloud of gas and dust, scientists thought the picture of interstellar bodies was becoming cleaner. We had mysterious Oumuamua without a tail and with incredible acceleration, and there was classic Comet Borisov with a huge tail and strange composition, 2 completely different objects from 2 different worlds. Experience discovering Comet Borisov sowed doubt among scientists, and we really thought we'd have to wait a very long time for another Oumuamua-like object. Was it just dark comets or proof of alien life? As we know, space doesn't like simple answers. Just when astronomers were getting used to the idea that interstellar visitors are either strange dark comets or ordinary icy nuclei, the universe prepared a new surprise. On July 1st, 2025, 4 telescopes from different continents simultaneously detected something incredible. An object appeared in Leo constellation, racing toward the solar system's center at 58 kilometers per second. Its trajectory left no doubt. The 3rd interstellar messenger had arrived. But this messenger immediately broke all the rules. It forced us to reconsider everything we knew about small cosmic bodies. Interstellar giant races toward Sun. Scientists baffled by 3-eye atlas behavior. That was the New York Times headline on July 5th. Within hours, the article became one of the most read in the publication's history. World media was swept by waves of speculation. Fox News devoted a breaking news segment to the object, where astrophysicist Neil deGrasse Tyson tried to calm viewer panic. Nature published an editorial urging readers to approach news about the new object thoughtfully. Views of Don't Look Up on streaming platforms approached premiere numbers. Social media exploded with conspiracy theories. Within the first 24 hours of 3-Eye Atlas discovery, TikTok was flooded with videos speculating about the object's alien nature, and the hashtag #AtlasIsAlien got over 2 million mentions on Twitter. Users published comparison tables constructing Atlas size with fictional alien ships from movies. Amateur astronomers worldwide admitted they'd never seen anything like it. All this resulted in Amazon reporting explosive growth in emergency kit, canned food, and water filter sales. Some US stores completely emptied their shelves of canned goods, condensed milk, and grains. Religious communities also became active. Atlas was compared to the approaching apocalypse and seen as fulfillment of biblical prophecies. The world was gripped by mass hysteria, digital panic that snowballed into practically every internet user's consciousness. But this isn't the first time such a story has happened in history. Once before, humanity experienced terror from another comet, proving how scientific discoveries can become sources of universal fear. This was 1910. French astronomer Camille Flammarion learned over his spectrometer at his observatory. What he saw in the spectrum of the approaching comet Halley made him goosebumps. The comet's tail clearly showed cyanide gas lines, one of the deadliest poisons known to humanity. Besides science, Flammarion popularized it. He authored bestsellers and was one of his time's most influential intellectuals. Simply put, this man's opinion was highly respected. When he published his conclusions, the world literally froze in terror. According to astronomers' calculations, on May 18th of that year, Earth would pass through Halley's comet tail for several hours. As Flammarion declared, cyanide gas will permeate our atmosphere and possibly destroy all life on the planet. Public reaction was immediate. In New York, people lined up for gas masks, enterprising merchants started selling comet pills as protection against cyanide poisoning. The pills was actually sugar, sold for $5 per packet. In Chicago, on the day of passing through the comet's tail, workers went on strike, saying they wanted to die at home, while in Georgia, about 300 religious sect members barricaded themselves in mines, believing poisonous gas wouldn't reach them there, and didn't leave their shelter for several weeks. Rich Europeans bought alpine trips, believing mountain air would save them from poisoning, while poorer residents rushed for oxygen tanks. On May 18, 1910, people anxiously watched in the sky. They were literally prepared to meet the end of the world. But something incredible happened. Absolutely nothing occurred, as some scientists had predicted. Earth passed through the comet tail without consequences. This story became one of the brightest examples of how scientific information transmitted without proper context can generate mass hysteria. However, humanity apparently doesn't want to learn from its mistakes. More than a century later, we've again become panic organizers. First in 2017, when Oumuamua's appearance generated speculation waves about the object's artificial origin, and now in 2025, 3-Eye Atlas approaches us, the third interstellar wanderer, again posing humanity's eternal question. Are we alone in the universe? Despite new century technologies, human nature remains unchanged. We still crave intrigue and still fear the unknown. This is where 3i Atlas' amazing story begins, an object that will provide answers to questions that have tormented humanity since first looking at the starry sky. But what exactly about it captivated the scientific community and caused such massive waves in ordinary people's hearts? To understand this, we need to dive into the chronology of events. On July 1st this year, the Asteroid Terrestrial Impact Last Alert System performed its usual task of scanning the sky for moving objects. Project Atlas consists of 4 telescopes located in Chile, South Africa, and Hawaii. Each telescope takes about 800 images nightly, but on this specific night, the telescope in Rio Hurtado reported observation anomalies. Atlas telescopes are notable for their ability to survey the galactic plane, the bright disk-shaped region of our galaxy where most of its mass is concentrated. This distinguishes Atlas from other surveys like Pan-STARRS and Catalina, which are too sensitive to photograph this galactic region without overexposure. Towards Sagittarius constellation, the Atlas telescope took 4 30-second exposures and detected an object heading straight for the solar system. Initially designed A11PL3Z, it quickly attracted attention from the Minor Planet Center in Cambridge. This organization issued a bulletin about the new object detailing everything known about it, including its flight trajectory. It turned out the object had appeared in telescope views 2 weeks earlier, allowing conclusions about its hyperbolic and highly elongated orbit, so elongated that it confirmed the object's extrasolar nature. The object was dubbed 3i Atlas. Observations showed it had a coma and diffuse halo of dust and gas formed by water ice sublimation under sunlight. This data confirmed 3i Atlas is a comet. Several important conclusions were also made. Most importantly, the comet poses no threat to our planet. At maximum approach to Earth, it will be over 200 million kilometers away. 3i Atlas orbit has a very high eccentricity, about 6. For reference, an ellipse with 0 eccentricity is a circle, while 1 is enough for an object to escape the gravitational field it orbits. Thus, with eccentricity 6, this comet has one of the most extreme hyperbolic orbits ever determined. Even more surprising is 3i Atlas speed, currently about 58 km per second, simply design speed, the highest of all similar objects we've ever observed. Remember, Oumuamua and Comet Borisov speeds were 26 and 32 km per second respectively. Currently, the comet is approaching the inner solar system and a maximum approach on October 3rd. It will pass less than 1.5 astronomical units from the Sun, between Earth and Mars orbits. It will approach Mars 4 weeks earlier, flying past the red planet at 28 million kilometers. Unlike Oumuamua, discovered after passing closest to us, we have much time remaining for 3i Atlas. Over coming month, astronomers can study the comet using every possible method. Particularly, Las Cumbres Observatory telescopes conducted multi-hour observation sessions to determine object's light curve. A light curve graphs an object's brightness changes. Every object has a regular shape and different brightness from different angles. This especially applies to asteroids and comets with arbitrary rather than spherical shapes. When the brightness pattern begins repeating, it means the object completed one rotation. Time between repeating patterns determines the object's rotation period. 3i Atlas light curve measurements show the comet's rotation period is about 29 hours. To astronomers' surprise, this is much longer than expected. Oumuamua's rotation period was about 8 hours. Magnitude measurements also showed 3I Atlas is the brightest interstellar object discovered, indicating its large size. It's 10 times brighter and several dozen times larger than Oumuamua. Despite its size, 3I Atlas is very inactive as a comet. It has a weak coma, the diffuse halo of gas and dust formed by cometary nucleus sublimation under sunlight. The coma is visible in this image as a fuzzy patch around the nucleus. Due to long exposure, stars appear streaked against the moving comet. Besides its coma, 3I Atlas has a tail extending 3 arcseconds across the sky at about 280 degrees. Thus, this comet appears several hundred times smaller in the sky than comet Hale-Bopp. Amateur astronomer observation showed 3I Atlas' tail extends over 25,000 kilometers. These same amateurs created many stunning comet images. Just look at them, absolutely captivating. We've examined the comet's brightness, rotation period, and activity, but what about its surface composition? In this regard, 3I Atlas resembles its predecessors. Like Oumuamua and Borisov, it's significantly redder than the Sun and slightly redder than outer asteroid belt objects. Such coloring is characteristic of objects containing carbon gases or atomic oxygen, but these haven't been detected on 3I Atlas in necessary quantities. Another explanation for the comet's red glow is that 3I Atlas is very ancient. Estimates suggest the approaching celestial body's probable age exceeds 7 billion years. Just imagine, 7 billion years. When the solar system was just appearing, 3I Atlas had already been cruising the galaxy for its 4th billion years. This characteristic distinguishes 3I Atlas from other extrasolar objects. However, there's a third explanation for the comet's glow, the most interesting one. I think some of you came here for this. This explanation is that 3I Atlas is artificially made. Professor Abraham Loeb, whom I mentioned earlier, advocates and initiates this hypothesis. In a CBS interview, Loeb stated he estimates 3I Atlas artificial origin probability at 60%. For most colleagues, this statement was like a bolt from the blue, since we're not talking about some fantasy film but a real object flying through the solar system. From my story, it might seem Loeb isn't particularly loved in scientific circles, but that's not true. Loeb is a serious scientist, author of hundreds of scientific papers, but he's become the main advocate for the hypothesis that some interstellar objects might be artificial. When we're visited by an object from another star, we need to consider all possibilities, Loeb explains his position. He even created a special scale from 0 to 10, where 0 means definitely natural object and 10 means definitely artificial object. 3I Atlas scored 6 out of 10. In his scientific paper with the intriguing title Is the Interstellar Object 3I Atlas Alien Technology?, Loeb goes further. He suggests the object might be not just technological, but hostile. Sounds like a Hollywood blockbuster scenario, but this is serious scientific research. Here's why we should take it seriously. Loeb presents several arguments that seem genuinely strange. Imagine instead of a regular taxi, a whole cruise ship pulls up to your building. That's exactly the situation with 3I Atlas. An object this size, 20 kilometers diameter, should be accompanied by a million smaller objects up to 100 meters, but they're not found. Even stranger is Atlas' trajectory. Its orbit aligns with the solar system plane within 0.2% accuracy. Imagine ordering a taxi specifying only the general area to visit, but instead the car arrives not just in the designated area, but waits right at your house. That's roughly the same thing. Moreover, the comet passes near several planets. It crosses Venus at 97 million kilometers, Mars at 28 million kilometers, and Jupiter at 54 million kilometers. It seems like the object's trajectory was specially selected for studying the solar system. Finally, most intriguingly, Atlas reached its closest point to the Sun on the opposite sides from Earth, as if it's deliberately hiding from our telescopes at the most important moment. As Loeb suggests, this could be an intentional maneuver to avoid detailed observations. However, the scientific community remains steadfast. Loeb's hypotheses face considerable skepticism, and rightly so, because as Carl Sagan said, extraordinary claims require extraordinary evidence, but the presented evidence is quite ordinary. Spectral analysis showed 3I Atlas consists of roughly 70% rocky material and 30% water ice. Its reddish color is typical of ancient objects rich in organic compounds, exactly like those we find in the Kuiper Belt and beyond. As much as we'd like to believe otherwise, everything points to this being an ordinary comet ejected from another star system. Nevertheless, while astronomers methodically studied data and scored points for Atlas' natural origin theory, the public panic situation continues escalating. Perhaps it's because we simply want to believe something amazing and maybe even dangerous awaits us. In an age when Earth seems explored inside and out, though it's not, space remains the final frontier of mysteries. The thought that somewhere among the stars are other civilizations sending us their probes excite imagination more than any scientific discovery. The famous WOW signal has kept interested people on edge for 5 decades now. Abraham Loeb understands this too. I'm not claiming Atlas is an alien ship, he explains. I'm simply saying we should consider all possibilities. Science advances when we're ready to think beyond the familiar. There is truth in this. Both hypotheses drive science forward. Without readiness to consider incredible possibilities, we'd still think Earth is flat. While Atlas continues its rapid flight toward the Sun, astronomers gather more data about it. Each new observation brings us closer to solving the mystery. On October 30th this year, when the comet reaches its closest point to our Sun, we'll get maximum information about its composition and behavior. Most likely, 3I Atlas will turn out to be exactly what most scientists expect: an ancient comet from another star system carrying information about distant worlds. But does this fact make it any less amazing? Watching the 3I Atlas story unfold, I can't help thinking about how this cosmic event reflects our times. We live in an era when information spreads at light speed, not just literally, but wisdom keeps pace at the same snail's pace as thousands of years ago. On one hand, it's amazing to see how quickly the scientific community mobilized to study the new objects. Literally, within days, astronomers worldwide united efforts pointed their most powerful telescope at the approaching comet and obtained unprecedentedly detailed data about its composition and behavior. This is a real triumph of scientific thought. On the other hand, I'm surprised by the gap between scientific facts and public perception. While scientists offer increasingly sound ideas with each comet passage, mass consciousness continues believing conspiracy theories about government cover ups or alien invasion. We seem to live in two parallel realities. Maybe it's because humanity finds it easier to believe in the incredible but desirable than in something ordinary and boring. To be amazed by another interstellar object discovery, you need to choose one of two things: delve into complex sciences about galactic space structure, comets, and orbital mechanics, or simply believe in alien interference. The second is intuitively much more understandable, while real scientific knowledge requires effort to understand. This isn't a reproach to any viewers. Each such case becomes an exam for us. Are we ready to distinguish real mystery from our own fantasies? Oumuamua taught us that the most ordinary things can be completely unlike anything we knew before. Borisov showed that other star systems' comets are generally similar to ours, but with their own peculiarities. And 3i Atlas reminded us of human imagination's power, in both of the best and worst senses. But the most important lesson from July's story is a lesson in humility. The universe is full of objects we don't yet understand, and that's normal. We don't need to declare every new mystery proof of alien existence. Sometimes we should just admit we don't know something. We don't know something yet. Just imagine this object traveled through the galaxy for billions of years before our solar system was ever born. It witnessed the birth and death of several generations of stars, survived cosmic catastrophes to finally reach us and tell us its story. Perhaps in chasing signs of alien life, we're missing an equally amazing phenomenon: the very fact that the universe is large and diverse enough to send us such messengers from distant worlds. And even if they remain silent ice chunks, they still carry a message that we're not alone in this boundless cosmos. The next interstellar visitor is already on its way. Soon we'll learn to find such object monthly, and each time we'll face the choice: give in to the emotion and fantasies, or patiently gather facts to gain understanding, truly ready to encounter something currently beyond our consciousness. Most likely, Atlas will fly away into open space without revealing all its secrets to us. But it will leave us something more valuable: a reminder that the universe is much larger and more amazing than our boldest fantasies. Fantasies we discuss on this channel. And this is perhaps the most beautiful message any cosmic wanderer can bring.